Here's a chain rule question. F is a function of two variables, and the question is if f is defined as capital F x squared x cubed, then what's the derivative of f of x? Now, it's helpful if you think of an example that's more explicit. So let's just write down, say fxy, not xy, I would like u and v to be something like u squared plus v cubed, or v 3v, something like this, okay? Then if this was the case, then what is lowercase f of x? That would be capital F, we're trying to do this, capital F x squared x cubed, and that means I have to plug in x squared into u and then x cubed into v, so which is x to the 4, 3x cubed, and the derivative is easy to do, which is 4x squared plus 9x squared, and 4x cubed, 9x squared. Okay, so if f of u and v were explicitly given, this is an easy problem because all you have to do is plug in. But it's not explicitly given, and you have to use g and h, so this forces us to use the chain rule. So how do we use the chain rule? Well, f, because x squared is being plugged into u and x cubed is plugged into v, you can think of this situation as f being a function of u and v, and u and v both being functions of x. Okay, that's the dependence diagram. And the formula for the chain rule says that if you want to know how capital F depends on x, right, then x influences f in two different ways, right? Change of x brings change to f by going through u and another going through v, and you have to calculate them separately. First, this is calculated as how f changes when you change u times this is calculated by how u changes when you change x. Okay, and the same thing applies. How much f changes when you change v times how much v changes when you change x. Okay, so you have this, and let's continue on. In this example, what we have is u squared plus 3v differentiated by u is just 2u. v is considered as a constant. Du dx, well, we decide to have u as x squared, so derivative of u will be 2x. And then derivative of u squared plus 3v by v, you're treating u as a constant, so this will become 0 when you differentiate. You only have 3v differentiated by v, which is just 3. And since v is x cubed, if you differentiate x cubed by x, you get 3x squared. And then if you want to see why this matches with your previous answer, you see that indeed, if u is x squared, and v is x cubed, replacing u by x squared does recover the same thing. These two are the same, these two are the same, right? So so this question is asking us to use the chain rule because it's forcing us to do so by not explicitly giving us what FUV is. It's just telling us to use G and H, which are partial derivatives. and we can, but we can still get a hint because now I can just delete everything, or let's just delete everything and then start afresh. Okay. So what's our idea here? The idea here is that you have this f of x, which is defined as f of uv, but into u you have x squared plugged in, and into v you have x cubed plugged in. That's what it is. And if that's the case, then our previous explanation of the dependence diagram, f is a function of u and v is a function of x, still applies. And we can say that the chain rule is change of f over change of x is how f changes as it goes through u, and change of f times change of v times dv dx. This is how f changes as it goes through v, right? So there's one way that goes through u, another one that's going through v, and that's this one and this one. They add up, okay? Okay, so let's think about this. I told you that f sub u is just another way to write down round f round u, and there's still another symbol, which is this. All three are being used. So indeed, this, which is f differentiated by u, is really g. Okay, so this is g uv, and then du dx. Well, u is x squared, so if you differentiate by x, this is 2x. In the same way, this is f differentiated by v, so we're going to use this h uv, and then dv dx is the derivative of v, which is 3x, x cubed differentiated to 3x squared. Okay, and the thing is, on this side, however, if we want f prime of x, although it's true that f prime is this, since f prime of x has no mention about u and v, you should rewrite this so that u is replaced by x squared, v is replaced by x cubed. Okay, and that's it. That's the answer to part A. Now what about part B? Well, use the same argument, f of x. Let me use a different color. So you still use that f of x is equal to f of u and v, and u is equal to 3 and v is equal to x. And again, it's the same kind of diagram can be used. Now, u is really a constant function, so really u doesn't depend on x. So you might just not write this bar and just say f is a function of u and f is a function of v, and v only depends on x. So you can certainly write down the chain rule using this diagram, in which case you would write df dx. X influences f only through v, so this would just be round f round v dv dt dv dx. And you can certainly write the answer like this, but it doesn't really hurt to say u is a function of x, but it's like plus 0x. Okay, because then we can use the same exact chain rule, except that when you do derivative of u with respect to the derivative of x, you get 0, right? So either way, you're going to end up with either this one, or you can say this is the derivative GUV. It's the same story, but u prime is now 0 because constants become 0, right? Plus HUV, and v prime is just 1. So it's just h of u and v. Okay? And if you want df dx, then you would want to differentiate this by x, right? So this is same thing as this one, which is same as this, and that's equal to h of u is 3 and v is x. So done. So that's what it is. Okay, so hopefully this example made you see how chain rule works. And here is another example. So in this case, w is a function of x, y, and z, and then x, y, z are all functions of t. So that if you want dw dt, this must be sum of 3 different influences. Okay, so there's a round w round x dx dt plus round w round y dy dt plus round w round z dz dt. And you just have to calculate one by one. Okay, so dw dx, well, you're treating y as a constant, z also as a constant, so if you differentiate this by x, that's easy. It's just x differentiates to 1, but since y is a constant multiple, that just stays, whereas y over z is both just a constant, so when you differentiate a constant, that becomes 0. Okay, so that's the partial times dx dt. Well, the derivative of x with respect to e is 5 times e to the 5t. So that's just the first part. Now what about round w round y? Well, you now see 2 y's in this. Here you have a y here and a y there. Okay, these are the variables, whereas the x and z are just constants, right? So here, these are constant multiples, so just think of this as x times 1 over y, and you differentiate 1 over y, and 1 over y differentiates to negative 1 over y squared. Hopefully you know that. Okay, 1 over y prime is negative 1 over y squared. Okay, and then if you differentiate y, that's 1, so it's 1 over z. And then when you differentiate dy dt, you're trying to differentiate this. 2 differentiates to 0, sine differentiates to cosine, so this is cosine t. And then plus, if you differentiate by z, this is x over y is considered as a constant, so that just goes away. And y is a constant multiple, so if you differentiate y over z, where y is a constant multiples can be pulled out, and you differentiate 1 over z. And the same formula holds, right? And y is multiplied, so you just multiply. So that's the derivative. And then you multiply by the derivative of z, which is 2 differentiate to 0, but cosine prime is negative sine. With the chain rule, it's negative 7 cosine 7t. And you just simplify this. It said do not write x, y, z in terms of t, so you just simplify this as it is, and that should be the answer. Now for part B, how would you find dw dt when t is 0? Well, when t is 0, you have to know the value of x, y, and z. X would be e to the 0th power, which is 1. y would be 2 plus sine of 0, which is 2, and z would be 2 plus cosine of 0, which would be 2 plus 1, which is 3. So you have 1, 2, and 3. And then now you have dw dt equals to 1 over y is 2, 5 times t is 0, so it's going to be 1. So t is 0, so e to the 0th power is be 1. So that's the very first one. Plus x is 1 times negative 1 over 2 squared, plus 1 over z is 3, and cosine of 0. Yeah. Oh, by the way, I made a mistake. This should have been sine, right? Okay, and then when you plug in 0 to the last one, you get sine of 0, so that's 0. Okay, so that's what we need. This is 5 over 2 plus negative 1/4 plus 1/3. And then cosine 0 is just 1. And I think these have common denominators over 12, so let's just put over 12. 6 times 5 is 30. 3 times 1 is negative 3. 4 times 1 is 4. So the end result is 31 over 12.